Welcome to the Sleep to Dream Analytics Explainer video, where better sleep starts with better understanding.
Ever feel like you're just running on fumes? We all do, right? And we all reach for something to keep us going, to stay sharp, to just stay awake. Well, today, we're going to pull back the curtain on the science of wakefulness and see what these things are actually doing inside our brains. You know the names. There's the coffee that gets your morning started, and then there are powerful prescription drugs like Adderall and modafinil. The goal is always the same. Flip that on switch in our brain. But here's the thing, they don't all flip the same switch. The way they get you to that state of alertness is dramatically different, and understanding that difference is absolutely key.
So, just so we're all on the same page, what are we even talking about here? The official term is central nervous system stimulant, but, as you can see from this definition, it's a really broad category. Basically, if it makes you feel more awake, more alert, and less tired, it fits under this massive umbrella.
To really understand how most of these stimulants get the job done, we need to introduce the main character in this story, a super important brain chemical called dopamine. The easiest way to think about dopamine is as the gas pedal for your brain's alertness engine. When dopamine is flowing between your neurons, you feel motivated, you feel focused, you feel awake. It's the signal that screams, hey, pay attention, this is important. The powerful stimulants we're talking about all work by finding clever ways to just slam that pedal to the floor. So how does your brain usually manage this signal? Well, it's this beautifully efficient little system. A neuron fires, it releases some dopamine, which crosses a tiny gap to deliver its wake up message. And then, and this is the most important part, a little protein called the dopamine transporter, or DAT, acts like a tiny vacuum cleaner, sucking the dopamine back up. This cleanup stops the signal and recycles the dopamine for later. Now remember that vacuum cleaner, the DAT. It's the main target for our first class of drugs. All right, let's start with one of the oldest and frankly most powerful tools in the stimulant toolkit, amphetamines like you'd find in Adderall. This is what we'd call the brute force method for jacking up dopamine. And this stuff has a wild history. It was actually created in a lab way back in 1897, but for decades, nobody really knew what it did. Then, during World War II, its ability to just erase fatigue made it a military go-to. I mean, get this, 72 million tablets were issued to British troops alone. That's just mind-boggling. It was only after the war that its serious potential for abuse became clear and its use became way more restricted.
So how does it achieve such a powerful effect? Well, it's not subtle. Amphetamine basically hijacks that dopamine recycling system we just talked about with a really potent one-two punch.
Okay, first, it jams the vacuum cleaner. It physically blocks that DAT protein, so any dopamine that's been released just hangs out in the synapse way longer, sending its signal over and over again. But then it does something even more dramatic. It actually gets inside the neuron and forces that same vacuum cleaner to work in reverse, so it starts actively pumping dopamine out of the cell. So think about it. It's not just stopping the cleanup. It's forcing the neuron to dump its entire supply. It's a massive, uncontrolled flood of dopamine. And as you can probably guess, this brute force approach has consequences. Because amphetamine also messes with other systems, like norepinephrine, it can lead to this whole host of side effects. Everything from feeling irritable and agitated to serious cardiovascular stuff like heart palpitations and high blood pressure. It's a very powerful tool, but it comes with a pretty significant cost.
Okay, so if amphetamine is the sledgehammer, what does a more modern, more refined method look like? Well, that brings us to modafinil, which takes a much more surgical approach to the exact same problem.
Modafinil was approved back in 1998, and it pretty quickly became a go-to first-line treatment for things like narcolepsy. And why is that? Because while its goal is also to increase dopamine, its method is way more specific, and that leads to a very different experience for the person taking it. And the science really confirms this difference. You see this quote here from researchers Nishino and Minya. They're basically saying that all the evidence points to one primary action. Unlike that two-pronged attack from amphetamine, modafinil really just focuses on one part of the process. And this right here is the key difference. PET scans of the human brain show that a normal dose of modafinil blocks about half of those dopamine transporters, those little vacuum cleaners. It only blocks the recycler. It doesn't do that second, crazy thing of forcing the neuron to dump its reserves. The dopamine that gets released naturally just gets to stick around a little longer. It's a precise nudge, not a sledgehammer.
This slide really just captures the whole difference perfectly. Amphetamine blocks the cleanup and forces a massive release. Modafinil just blocks the cleanup. This one difference is the whole reason modafinil generally has a lower potential for abuse and fewer of those intense cardiovascular and mood-related side effects. It's just a more controlled, more targeted way to enhance the brain's own signals.
But hold on, what about the world's favorite stimulant, the one that most of us run on every single day? It turns out caffeine is playing a completely different game. It doesn't really touch the dopamine system directly at all.
Here's how it works. As you go through your day, a chemical called adenosine slowly builds up in your brain. You can think of adenosine as your brain's sleep-promoting signal. It's the biological brake pedal that slowly makes you feel more and more drowsy. Well, caffeine's molecular shape is so similar to adenosine that it can fit perfectly into the adenosine receptors and just block them. So caffeine isn't pressing the gas pedal like the other drugs, it's simply stopping your brain from being able to press the brake.
So we've seen the sledgehammer method, the targeted scalpel method, and the cut the brakes method. So what's next? Well, scientists are now exploring completely new pathways to promote alertness.
The future of wakefulness looks incredibly diverse. Researchers are developing drugs that could actually replace hypocretin, a key chemical that's lost in people with narcolepsy. Others are targeting the histamine system, the same one involved in allergies, to boost arousal. And still others are looking at the brain's main go signal, glutamate, or even targeting specific hormone pathways. The goal is always the same: find more effective ways to create alertness, but with fewer side effects.
And this all leads to a really fascinating final thought, doesn't it? We've gone from the sledgehammer of amphetamine to the scalpel of modafinil and beyond. As our understanding of the brain's incredibly complex circuitry for wakefulness gets more and more detailed, the ultimate question becomes, can we actually engineer alertness itself? Can we design a state of perfect focus, completely free of jitters, crashes, and all the risks? The science seems to suggest we're getting closer every single day.
Thank you for watching the Sleep to Dream Analytics Explainer video. We hope you sleep well and dream easy.